All right, so now what are acids like? What are their properties, their characteristics? So, what we already know about acids and bases is they have acids have low pH and they are sour. So you might have picked that up from the last thing. And bases have that high pH and they are bitter if you were to taste them in general, but don't taste them because they're bad for you. And they both can burn you. Okay, so we already knew an acid can burn you, it can damage your skin, it can even eat away at a body if you watch Breaking Bad, but so can a strong base. Okay, so they can both burn you. Um, but what you don't know is why. Like, why do they act this way? And that's what this do now is about. It says make a sentence out of the words ionic, ionize, ion, electrolyte. So what I wrote was ionic substances ionize, break into ions. So then there are electrolytes because now they've broken into these charged pieces so they can conduct electricity. So I guess what that doesn't mention is that covalent doesn't do this. Okay, so normal covalent things don't do that. Only ionic substances will ionize. They'll break into ions and then they can conduct electricity and do all this cool stuff. Covalent usually won't break into pieces. But acids are special because they do. So acids are like these special covalent substances that do break into pieces and then they can do some stuff that ionic can do. All right. So acids are unusual because they are covalent molecules, but they can ionize when you dissolve them in water. No, so therefore, because they can break into little charged pieces, they are considered electrolytes. They can conduct electricity. And that gives them some different properties. And if you're wondering what makes acids so special that they get to ionize, is if you look at their electronegativity. So they do share electrons in a bond, which is what makes them covalent. They cooperate, but they have a really big difference in electronegativity. So they share, but they don't share very evenly and they don't share very well. Like this Cl is so much stronger. He's dying to just break away with these two electrons and leave and just become a negative ion. And the H plus will be left, or the H will be left as a positive ion. So they're covalent, but they're covalent that's like really ready to split because they're very different in electronegativity. So that's why they will ionize, break into a negative and a positive ion. All right, and so what is a base? Base is some sort of metal with an OH. We said that before. So that is ionic. So it's not really a surprise that it ionizes, not as special as acids. But it does ionize, so it can do a lot of the same stuff as acids. It can burn you, and it can conduct electricity because Na, the metal, the loser, will break away and become positive, and the OH will become negative, and that's kind of a characteristic of bases that you'll learn later. But because they do break into those kind of charged, free moving particles, they are really good at conducting electricity. So they are considered an electrolyte. They can conduct electricity. They are also, by the way, slippery. Like soap always feels slippery, right? And they tend to be bitter if you were to try soap, but don't because it can upset your stomach. And again, they have that pH greater than 7. They do tend to be with group 1 or group 2 metals, especially hydroxide bases. And that soap is usually just when you take a base and you combine it with any sort of fat or lipid. So soap in the old days was made from like whale blubber with a base like lye. Then we switched to like more plant-based oils like aloe as the fat. But you have to have some sort of fat and a base. And in the movie Fight Club, they use the fat from like leftover human liposuction. So that's kind of gross. But anyways, what you got to know about acids and bases is that they can both burn you and they can both conduct electricity. And a big part of that is because they will ionize, they will break into ions. And next time we'll talk about what happens when you put an acid on a metal.